Right, good evening and welcome to Mastera Online Class. By my watch, it is 2:28 a.m. I like doing my video early in the morning like this because of my son. He likes disturbing my video. Okay, this particular video I'll be talking about physics graph, practical physics graph. Okay, how to plot your graph, how to get your error in slope, how to use interpolation and extrapolation to get your table. Right? Okay. Now, in your physics practical, you have to be very careful with getting your table. So let's start from table first. In getting your table, first of all, if you are to do the practical, don't waste your time in doing all the practicals. Okay, all the experiment. Maybe, for example, they gave you a serial number, for example, and the serial number is maybe 1, 2, 3, 4, and then 5. Okay, don't waste your time in getting all of them. Don't waste your time getting all of them. So maybe they give you that here is your h, and your h is 0.18, 0.37, 0.84, then 1.10, and then 1.34. Okay, and then maybe you have to plot it against for example, your t, or you want to get maybe your t square, something like that. Now the only thing you need to do is just, as far as you know all these ones, okay, and then you need to feed the other one. And then when you did the experiment with 0.18, maybe you got that this gave you 2.65. I'm just using any number at all. Then do the second one, and the second one gave you 2.55. Please don't waste your time in doing the remaining three. No, use what we call interpolation and or extrapolation. Now, when do we call it interpolation? We call it interpolation when it is in between the two you have gotten already. Okay, maybe for this one now, you have that this is your h and this is your t. You have that when it is 0.18, that you got 2.65, and then when it is 0.37, that you got 2.55. Now, to get the next one, to get this 0.84, you will see that this 0.84 is not in between these two. It is just, it is outside these two. That's when you call it extrapolation, but it's the same thing. The difference is just the English. So then you now say that this one will give you x. Okay, so how do you interpolate or extrapolate? This one is called extrapolation, but maybe it fell in between like this. Okay, maybe you decided to get your number one and the last one, for example. You see that everything there will now become interpolation. So, but let me show you what to do. Now, what you simply need to do is just any pattern you decide to follow that pattern. Like myself, I like following everybody subtract the person above. Okay, so everybody should subtract this person above. So let's say we'll now say 0.84 minus the person above 0.18. Okay, all over this same person will still subtract everybody above. So everybody subtract this man. So 0.37 must subtract this 0.18 is equal to, so the same thing here, everybody here must subtract this person. So I have x minus 2.65 all over 2.15 and 2.55 minus the same 2.65. Okay, you've seen that now. So what do? You now get your answer. So let us get, this is called extrapolation. Some people like doing maybe this minus this and then this minus this, then they will not do the same thing. Any pattern you like to follow that same pattern. Anything you do to the left, do the same thing to the right, so that you don't make mistake. But for me, I like saying everybody must subtract this first person I've written. Okay, you can decide to follow from up down. You can say let everybody subtract the person down. You must get the same answer. So I have what? 0.84 minus 0.18. So I have 0.66 here all over 0.37 minus 0.18. So I have 0.19 is equal to, here is x minus 2.65 all over 2.55 minus 2.65. I'm having a negative answer. Okay, so I'm having minus 0.1. Now let us cross multiply. If you cross multiply, or just say this time this divided by this. Okay, if you do cross multiply, you have x minus 2.65 is equal to this time this divided by this. Okay, let me get everybody here. So this time this, so I'll say times 0.66. Okay, then divided by 0.19. So I'm having minus 0.3 approximately 35. Okay, so this one coming here will now be x will now be minus 0.35 plus 2.65. So I'm going to have plus 2.65. So I'm going to have 2.30. Okay, so this one gave me 2.30. So I'm having here 2.30. And when I did my practical, I'm having uh, 2.20. You see, it is something very close. So you are going to get the same answer. Okay, and they will not know, it's not possible. So everybody must not get the same thing. So you see that I got 2.3, and this 2.3 I got was because of my approximation. Because I approximated when I did you can do your normal cross multiply, but what I did here is just to keep this one to stay alone. These people will just go up and multiply this, then divide by this. Okay, so when I did this, I approximated this into 3.5. I didn't even I use the number there. Okay, I didn't even I use the number there. I'm sure I'm going to get that 2.2. You see, so that is extrapolation. So the other one is interpolation. So let me now finish up what I have here. So this one gave me 2.00, and then finally 1.80. So you try that, you must get the same answer accurately. So that is called interpolation. So instead of wasting your time in doing the graph over and over and over again, so use your interpolation or extrapolation. The same thing, whether it is interpolation or whether it is extrapolation, is the same thing you are going to do. Let everybody subtract. For example, okay, let me take this for instance, and then do extrapolation, interpolation. Let me say I don't have here. So I will say this is my h and this is my t. So I have that when it is 0.18, it is 2.65, and then when it is 0.37, I don't know what it is then, but I know that when it is 0.84, okay, it is what, 2.30. So it's the same thing. Just say that let everybody subtract the person on top. That's all. So just say 0.84, this person first, minus 0.18. Even if you like to start from here, just do the same thing. Anything you do to left, do to right, all over. Okay, I've done this minus this, so I'm going to do this minus the same person again. So 0.37 minus 0.18, so is equal to, let's do the same thing, 2.30 minus 2.65 all over x minus the same 2.65. So let us do our mathematics. So I have 0.84 minus 0.18. So I'm having 0.66 all over 0.37 minus 0.18. So I'm having 0.19 is equal to, subtract the other one, 2.30 minus 2.65. I'm having minus 0.35 all over. Then here I'm having x minus 2.65. So I can decide to divide these people and get a single answer. So I can say 0.66 divided by 0.19. So I'm having approximately 3.473 7. Let me approximate to 4 decimal place. Okay, then last I will now approximate to 2 decimal place. So, or I can even decide to use every number I'm having there. So minus 0.35 all over x minus 2.65. So this one will come down. Are you seeing it? This person is coming down. It was up, crossing equality sign to come down to divide this. So I can say divided by minus 0.35. Okay, so I'm having minus 9 point. Permit me to write here. I'm having that that is cross multiply. Okay, sorry, if I cross multiply, this one should be over 1. Since I have divided this, let me make this over 1. I'm crossing multiply, please. Crossing multiply means that these people can change position. Instead of using this to start multiplying these people to waste your time, let them change position. So if they are changing position, I'm going to have that x minus 2.65 is equal to what? Minus 0.35 divided by 3.4737. Okay, so now, because you can, the one you're looking for cannot be at the denominator, it must always be at the numerator. So I'll have minus 0.35 divided by 3.4737. Okay, so I have negative this. So permit me to clean this. So I now have that that x minus 2.65 is equal to, when I divided this, I had minus 0.1008. So this one coming here, it will now be x is equal to what? Minus 0.1008 plus 2.65. Okay, this will now be equal to plus 2.65. So I'm going to have 2.5492. Okay, so approximately 2.55 approximately, and that was exactly what I got, 2.55. You see, it works like a magic. It doesn't fail, whether interpolation or extrapolation. Just know that everybody should subtract the one up, then you are good to go. So don't waste your time in doing your in repeating all the experiment. No, we don't have such time. So now the next thing I need to teach you is plotting the graph. Now anytime you want to plot graph, I'm sorry I don't have graph here, but I will make it in a way that you are going to understand it. Okay, now let me say that this is your graph sheet. For instance, this small place is your graph sheet. Now what do we do in drawing your x and y axis? You know that the vertical line is called the the y axis, while the horizontal line is called the what? The x axis. Now to draw your x and y axis, the first thing you need to consider is, now for example, let's say that they say plot this one on the x axis and plot this one on the y axis. That's what they said. Okay, now for me to draw the y axis, I need to consider what is x. For me to draw the y-axis, listen, for you to draw the line of y-axis, you must consider the value of x. What do I mean by considering the value of x? Now, if the value of x are all positive, then I should draw it somewhere close to this place. Why am I drawing it somewhere close to this place? So that I will have space for the right hand side of x. And you know that right hand side of x means positive x. So that there will be enough space for the positive x, because everything here is positive. But if everything there is negative, then I have to draw it to this side. So that I will have enough space for negative x. You see the way you are considering. But if it is both negative and positive, then I will draw it in the middle. If I draw it in the middle, then I have space for positive x and space for negative x. That is why your what is it called? Your quadratic equation, they always draw it in the middle, because it always have the negative and the positive x. You get the point now? So the same thing is applicable for if you want to draw the x-axis. Now, I want to draw the x-axis, which is the horizontal axis. I want to draw it. I will consider my y. Now, if my y, for example, look at this one. This one is all positive. I have to draw it down here, so that I can have space for the positive. Up is positive y. I can have space for positive y. But let us assume that all of them are just negative. Then I don't need the positive y again, which means I have to draw it here, so that I'm having space for the positive y. Are you getting now? Then if they are both positive and negative, then what do? I can draw it somewhere in the middle. Okay, depending on if they are equal. But if you have more number, for the anyone you have more number, you know that I have more space there. Okay, maybe 3, I'm plotting 3 that are negative and then 2 that are positive. Then I should draw it maybe somewhere here, so that I will have more for negative. So you understand what I'm trying to say now? So that is that. Okay, now since you have learned how to draw your x and y axis, so for me to draw this particular one now, all are positive for y. If I want to draw my y axis, which is my vertical axis, I'll consider my x everybody here are just positive, so I will draw my y-axis here, leaving space for my positive x, leaving space for my positive x, where I can plot my positive x. Now, another thing you need to do in your graph, when you draw this main line, you must cap it. It's a must you cap it, please. You must cap it. And when you cap it, you name it. You are not naming it x-axis. You are naming it what you are plotting. I am plotting h. Let me say that this h, we are plotting it in meters. I am plotting this, my h, in meters. You name it. Okay? Now, since my everything, my y, are all positive, I am going to draw this one down here so that I'm leaving space up for my positive y. Are you getting it now? So I will cap it again. You must cap it here. If you cap it, you will now write that you are plotting time in seconds. You are plotting your time in seconds. Okay? This one already will fetch you about maybe 1.5 marks. 1 mark, maybe they can say half marks. Maybe one mark, it will fetch you 2 marks. Okay, please. And do not shade. Please get a sharp pencil. Do not shade. Draw it straight. Don't shade. We don't shade in graph. Okay? And then don't use pen. We don't use pen. We use pencil. Please use your pencil and the ruler. Okay. Now, since you have made space to do this, now the next thing to do is how to choose your scale. That's why they call it choosing scale. Is your choice. Okay. Now, if I want to choose scale for what I'm plotting in my y-axis, I can decide to take every 2 cm. Don't forget that in your graph, in most graph, the first big line, some don't really show big line, but if you count those small lines, if you get to the 10th number, the number 10, it calls 2 cm. Okay, each 10 lines, like all those small ones, 1 2 3 4 5 6 7 8 9, the 10th one is always shaded, it's always very bold. Okay, that is your 2 cm. So maybe I have this 2 cm. Let me say I have it 1 2 3 4 5 6 7 8 9 10. Now most of the time is always 10 or 11 or 9, depending on depending on how you want to draw your own. Okay, let me assume that it is 9. Now how do you choose your scale? Let me equally check if my time is still going. Okay, how do you choose your scale? Watch me. You check what is the highest value you want to plot for the y-axis. The highest value I'm plotting for the y-axis is what? 2.68. 2.65. Okay, 2.65 is what I'm plotting for the y-axis. I will now say I will divide it by the number of calibration. What do I mean by calibration? Since I'm using 2 cm, how many 2 cm do I want to use? For example, I want to use 1 2 3 4 5 6 7 8 9 10. I have 10 calibrations, so I want to use it for what? 10 calibrations. So I will divide it by 10 to get what each of them will be. So if I divide this thing by 10, I'm going to have 2.65 divided by 10 is giving me 0.265. Now, in choosing your scale, please, we don't use odd number as the last one. Please, we don't use odd number as the last one. Always use even number. And even number you use must be greater than or equal to this number. It can never be less than the number you got after dividing. For example, maybe I decided to use 0.26. I want to use just 2 decimal places. It's my choice. Now, this 0.26 is smaller than 0.265. I hope you know. So I can never use this. It will not work. It will not work because it will go outside my last point. I can never use something that is less than. It must be greater than or equal to. Okay, so I can decide to use maybe 0.266. This is greater than this, and this is an even number. We use even. So this is very, very okay to use. But if you decide to use just 2 decimal places, then instead of using 27, approximately 27, I cannot use 27. 27 is okay because it is greater than, but I cannot use 27 because it is what? Odd number. So what do I use? I can use 28. 28 is an even number. It's very, very okay. So now what do? You now write in the first place 0.28, for instance. Now, how do you get what you'll be writing in the next one till you get to the last point? Is keep adding this your scale. Any answer you get plus your scale. So I'll say the last answer here is 0.28 plus that my scale, which is 0.28. I'll get 0.56. So here is 0.56 plus, that my answer again, plus 0.28. Just keep adding 0.28 till you get to the last person. So you have what? 0.84 plus what again, plus this again, 1.12 equal to 1.40. I got 1.4 here. I cannot write 1.4. I'm using two decimal places, so all of them must be in two decimal places. So it will be 1.40. Okay, equal to again, you have, that is this last answer plus this. You keep adding this your scale till you get to the last point. So I have 1.68. So the next one is 1.96. The next one 2.24. The next one 2.52. Then the last one is 2.80. Now you see that this 2.80 is greater than this highest number, so it will fall in between your point. But if you use something that is less than this, the last answer you get here must be less than this. You see, it will not be outside, it will fall outside, it will not enter inside your graph. So that is why we use something that is greater than. Okay, first of all, it must be greater than. Second of all, it must be what? An even number. Okay, so now you have gotten this. So let's do the same thing for x-axis. Remember the same thing again. 10 lines. One, two, those small one. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th one is always big and long. So that 10th one is your 2 cm. Okay, sorry, you must write here that you are using what for your y-axis? Your scale. Sometimes they put option for scale. For y-axis, I am using that each 2 cm is equivalent to, what am I using? Is equivalent to 0.28 units. Okay, you can put units there. Okay, or you just write 0.28. Now the same thing here. So let us find out what we are going to use for 2 cm. So you are going to count the number of calibration, because choosing of scale is equal to what? Highest value divided by number of calibration. Okay, so my highest value I'm going to plot in the x-axis is 1.34. So 1.34 divided by the number of calibration. Let's say I have 1, 2, 3, 4, 5, 6, 7, 8. Most of the time is always 8, depending on how you place your this is sometimes 9, okay, or even 7, depending on, just anyone you like is okay. Okay, so but my own, I decided to use 8. So if I divide it by 8, what do I do? That is 1.34 divided by 8. What do you have? I'm having 0.1675. Now what can you use here? If I want to still use the same two decimal places, can I use 0.16? No. Why? Well, 0.16 is an even number, correct, but I cannot use it because 0.16 is smaller than what I got after dividing. I cannot use this. Can I approximate to 0.17? Yes. Is this bigger than this? Yes, it's bigger than this. But is this an even number? No, I cannot use this. So what do I use? I can use 0.18. It is your choice. That's why they call it choosing of scale. Anything you like, choose. But what you're choosing should be correct. So therefore, I'm going to use 0.18. So keep adding this 0.18, you get to the last point. So 0.18 plus 0.18. I'm going to have 0.36 plus that same 0.18 again. I'm going to have 0.54 plus that same 0.18 again. I'm going to have 0.72 plus that same 0.18 again. I'm going to have 0.90 plus that 0.18 again. I'm going to have 1.08. You keep adding it, you get to the last point, 1.26, and then finally I have 1.44. You see that 1.44 is bigger than this 1.34, so it will enter here. It will not fall outside here, it will enter here. So that is why we use the number that is greater than. Okay, so you now come and write again that your scale for the x-axis now, your scale for the x-axis is now that each 2 cm is equivalent to 0.18 units. Okay, that is how to choose scale. Now the next thing is now how to plot your graph. Now the problem in plotting your graph is that how do you find all these points. For example, how do I find 0.18? Okay, 0.18 is here. Okay, let's say, how do I find 0.37 from this place? It will be very, very difficult for you to do. So what do? Convert everything to what I call box. Convert it to box. This is X and your Y. Now, how do you convert them to box? Watch me. Let me do for the Y axis. For the Y axis, you know that all this line, I call them box. Box number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, number 10. So you tell them that what? 10 boxes gave you this number, which is your scale, gave you 0.28. Now, how many boxes will give you, you put the first value of what you are plotting in your Y, will give you 2.65. You do your cross multiply. So my cross multiply will give me that this time this divided by this, because this one is coming like this. If this one is multiplying, so it will be divided by this. Or do your normal cross multiply and then know what to do. Okay, this time this. Now that your X box will now be what? 10 times 2.65 now divided by what? 0.28. So you now have what? I'll be having 10 times 2, then divided by 0.28. So I'm having approximately, I have a 94.6 blah blah blah, but approximate it to whole number is going to give me 95 boxes. So you write it here, 95 boxes. So remove this one now and put the next one. So the next one I'm putting is what? 2.55. So I'll put what? 2.55. If I put 2.55, I got 91.07, which is approximately 91. So remove the next one and put the next one, which is what? 30. I'm going to have approximately 82, okay, boxes. So the next one I'm going to put is 200. I'm going to have 71 approximately, and then finally I'm going to put 1.80. So I'm having approximately 64. Okay, so now that is for your Y. So now let's do the same thing for X. For X, we know that this calibration is my boxes. Box 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On the 10th box, I'll tell them again, 10 boxes gave me this 0.18. Now, how many boxes will now give me? I will take the first one. The same 0.18 is going to be, you are going to get 10. This time this divided by this. So it's going to be X boxes will now be what? 0.18 times 10 divided by this time this divided by the same 0.18. You're going to get 10 boxes. So it's obviously 10 boxes. So now remove this one now, this one on top, and put the next person. It's only this one on top you'll be replacing. So I'm going to have 0.18 times 10 divided by 0.18 times 10 divided by 0.18. I'm going to have 10 ahead. So if I remove it, I'll put the next one. I'm putting 37. I'm going to have approximately 21 boxes. 21 boxes. I'll put the next one. The next one is 84. I have 84, approximately 47 boxes. So the next one is 1.10. I'm going to have approximately 61 boxes, and the next one is 1.34. 1.34. I'm going to have approximately 74 boxes. Now, with this particular thing now, you can even plot graph for 1 million people. Once you have gotten this, you can plot the graph for 1 million people. So I don't need this again. I'm now using my box. To get it. So let me draw my box so that I can clean them. So this is my X and Y axis. So I have 10, 95, 21, 91, 47, 82, 61, 71, and then 74, 64. Now, so if I want to plot this now, I'll be counting in terms of box. For example, this is 10 against 95. I'll say that here is 10, okay, against 95. I'll say 10, 20, 30, 40, 50, 60, 70, 80, 90. Let me say 91, 92, 93, 94, 95. So 95 is here. You trace it here and trace this one here. You are not drawing with your pencil. So this is where they will meet. I'm just showing you because I don't have a graph. This is where they will meet, for instance. So let's do the other one. 21 boxes and 91. This is 20, for instance. Then the small one is 21. Okay. Then I'm counting 91. 10, 20, 30, 40, 50, 60, 70, 80, 90. 91 is here. So this one coming here and this one moving here. So let me say they will meet here. I get it now. So the next one is what? 47 and 82. 47. Please let me check my phone. I don't know because I have low battery. Okay. So I have 47. 47 for X. So 10, 20, 30, 40. Let me see 41, 42, 43, 44, 45, 46, 47. Let me say that here is 47 against 82. 10, 20, 30, 40, 50, 60, 70, 80, 81, 82. So this one comes this way. So that is how you will now be merging them till you get your points. Once you get your points, you are good to go. So the next thing is now to draw your graph, to draw your line. Sorry, to draw your line of best fit. They call it line of best fit. Now let me teach you how to draw your line of best fit. For example, maybe I have this point, 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 maybe point and point. I'm just saying. Now, to draw your line of best fit, now, for instance, now, if I draw this thing like this, for example, if I draw this like this, now, I'm having 3 against 0 here. It is very, very wrong. When drawing your best fit, look at what you check. You will check if anyone that fall out here and the one that fall out here must be equal or one greater than each other. It's either I have that one is here and one is here, correct? Or maybe 2 is this side against 1, correct? Or maybe 2 here against 1, correct? Or maybe 3 against 2, correct? So they must be equal or one greater than each other. Are you getting it? So now, another thing you need to consider after drawing it is to know whether you have a negative slope or a positive slope. Now, if you draw your line like this, don't forget that you're going to trace your slope like this. Now, is your slope in the right-hand side? If your slope is in the right-hand side, then it is a positive slope. So you are going to say that what? Don't forget that slope is equal to what? Change in y, no, not change in y, but change in what is plotted along the y-axis against changing what is plotted along the x-axis. Okay? So don't mind me. I don't know. I was thinking, I don't know the one I plotted against anyone, but I hope you are getting it. So that I'm seeing that I made a mistake. So, but let me assume that this is what I plot along the x-axis. So it's going to be change in h over what? Change in t. Please don't write change in y against change in x. You are not plotting y against x. In fact, you are going to name your graph that this is the graph on top. It's not inside your graph, or there's a space on top, or in the other sheet. You tell them that this is on top is okay. This is the graph of h in meter against what? T in seconds. So what you are plotting is h against t. So you cannot tell me x and y. You are not plotting x and y. So this is going to be what? Your h2 minus h1 all over what? T2 minus t1. Okay? So you now trace what is your T2, what is your T1. So trace this point to this side, trace this one to this side. Then trace this side to this side, trace this side to this side. And then make sure that the point where you are choosing this particular line must, you know that all these things are like boxes like this. How do I draw the boxes now? For example, make sure that where you are choosing that point is where the graph passes in the middle here. So if you are choosing it like this, so that you can trace that this one goes this way and this one comes this way. It mustn't be on the big line. It could be on the small line, but don't go and choose it. For example, somebody will come and choose from here and draw here. So where are you choosing to? You see that this line is entering into the middle, so it will not work. So make sure that it's following a particular line so that you can easily trace it to where it is moving. Okay, I'm saying a lot of things in this video. Okay, but thank God. So now this is, you call this side your T2, here your T1, then here your H2, and here your H1, the one down, and here your H2. You get the point now. So this is your change in H, and then your change in T. So that is that. This is a positive graph. Now, what happens when it is a negative graph, a negative slope? Sorry. If it is a negative slope, then it will go like this. If it goes like this, you see now that your slope will now be on the left-hand side. If your slope is on the left-hand side, you are choosing, you are moving, you are tracing this side with a dotted line, please. This one must be a dotted line. This side dotted line to trace what it is, this dotted line. Okay, so your slope is still changing your h all over, your changing your t. Sorry, changing capital letter T, which is what? But the problem here is that you're going to say H2 minus H1 all over T1 minus T2, so that you will get a negative answer. Are you getting it? You get one of them must switch. It's either you switch this one or you switch the one down. I can say H1 minus H2, then come in here and write it normally, 2 and 1, so that I will get a negative answer, showing that it is a negative slope. Okay, and the SI unit of your slope, very, very important. Any answer you get after putting the value, you must put it in meter per second. Meter per second. Are you getting it? This boy has woken up. Okay, so that is that. Are you getting it? So now another problem students face is how to trace and know that particular number that must be here, or that number that must be here. Let me do one or two for you. Now, maybe this thing fell here and I don't know how to get the number. I'll use the same method again. I'll say that, watch, I'll say that 10 boxes, don't forget that this is 10 boxes. 10 boxes gave us 0.28. Now, we are not looking for boxes but a number. So let me count the boxes. I'll say 10, 20, 30, 40, 50, 60, 70. Let me say 70, 80, 81, 82. So this one fell at 82. I will now say 82 boxes should give me what? Go back. Go back. 82 boxes should give me what number? If you do your cross multiply, you must get that number here. Okay? So, come. This boy want to spoil my video. So the same thing is applicable this side. Okay, for example, maybe the thing fell somewhere here, you will do the same thing again. 10 boxes, 10 boxes gave you 0.18. Now you are not looking for box again to count the box. Now say 10, 20, 30, 40, 50, 60, okay, 50, sorry, let me say 51, 52, 53, 54. Let me say that it is 58 boxes. You now say 58 boxes should give you what? You now do your cross multiply to find that value that is there. You've seen how to get the value. Okay, so now the last thing I'm going to say for this video is, okay, and that thing is to get your interception. They can tell you to get your interception. That is the point where the line of best fit cut your y-axis. It's called your interception. So you need to find what this intercept is. Okay, so you can do the same thing again. 10 boxes gave you this. Now you now count the number of boxes where it cut it to get your interception. Now finally, the next thing and the last thing I'm going to say is how to get your error in graph. Your error in graph. Now the error in slope, sorry, your error in slope. The error in slope, the formula for error in slope, let's call it SG. SG is given by 4W over NR. That's the formula. Okay, 4W over NR. What is your N? Your N is the number of things you plotted. 1, 2, 3, 4, 5. We plotted number 5 things. So my N is 5. Okay. Now your R is the range. The R is the range. Okay. Then your W. Let me show you how to get your W. To get your W, okay, that's the last thing I'm going to do. SG is given by 4W over what? NR. And maybe I have my slope here. I have point, maybe point. Okay. You are going to take the one that is closer, the point that is closer to the line of best fit. I'm not going to choose this for this particular one. I'm going to choose the one that is closer to this place. Okay, and this one. So what do? You are taking the distance from here to here. That is your W. The distance from here to here is your W. How do you get that distance? Trace this point. Trace it to this place. And trace this one to this place. Okay? If you trace it, get the value here minus the value here is your W. Your W is now this distance from here to here. Okay, so my W will now be, let me say that any distance here minus this one is my W. It's not difficult to get. Then your range is if this value minus this value is your range. The value you got here minus the one here is your range. Then you are done. This is your, you now substitute it here to get your error in graph. Okay, so that is that for that. So any other thing? Okay, so nothing again. So thank you very much for watching this video. If you have any question, you can ask on the comment section and I will respond. I hope this video will help you. Please always like the video and comment. The more you comment and like, it helps the video go viral. Okay, thank you very much and God bless you. David, say bye-bye. Say bye-bye. Say bye-bye. You don't say bye-bye. Okay.